Okay, so this is 11.5.14. And we're going over the FIP quiz. How many shapes of orbital can exist on main energy level 3? The thing you have to remember in order to answer that question is that the number of shapes equals n. So on main energy level 1, it's 1 shape. On main energy level 2, it's 2 shapes. On main energy level 3, it's 3 shapes. You know, on main energy level 64, which doesn't exist, it's 64 shapes. It's always equal to the same, it's the same thing as the number of the main energy level. Okay, number 2, the three-dimensional region of space around the nucleus of an atom where Schrödinger's equations predict a high probability of finding an electron. That is called, that's the orbital. So that's the orbital. And we've been describing lots of them, s orbitals, p orbitals, d orbitals. We don't talk too much about f's and g's. Okay, so we've got orbitals. We've talked about lots of them. How many possible orientations exist for an s orbital? This is number 3. Of course, I had to give you all the options just to, you know, be mean and nasty and lay a tiger trap for you. S orbitals only have one orientation. There's just one way to put an s orbital, and that means we only have one s orbital. P orbitals have 3. I always have a hard time drawing the Z, and I drew those not in the order I usually say them, but the X, the Y, the Z, and of course those crazy, wacky, wild D orbitals have more orientations than you can shake a stick at, so I can't even draw them all. We have them sort of leaning over, and we have dumbbells and donuts. But the number of orientations is also, of course, the number of orbitals that you're going to have of that particular subshell. Okay, number 4, how many electrons can exist on main energy level 5? To do this, you have to remember something. So, number of shapes is equal to n. Number of orbitals equals n squared, and each of those orbitals can hold 2 electrons. So number of electrons is equal to 2 times n squared. So that was the key piece that you had to remember. And so, of course, the answer for 4 is 50 electrons. Okay. Number 5 is also answered by this same slide. How many orbitals can exist on main energy level 4? Well, you have to remember that number of orbitals is n squared. So energy level 4, 16 orbitals. Energy level 2, 4 orbitals. You can answer them for any orbital. Number 6, my favorite trick question. How many, and I should have put 21, how many electrons can any orbital hold? 2! Just 2. Not 1, not 3, 4 is right out. Just 2. Number 7, which orbital can be oriented along the X, the Y, or the Z? Well, that, of course, would be a p orbital. Number 8, I was really kind of proud of this question. It was tricky and mean and evil. My favorite kind. The subshell that is comprised of 3 orbitals on main energy level 4 is what? So if it's got 3 orbitals, we know that it's a p subshell. If it's on main energy level 4, it's the 4p subshell. So having the word 3 in there was tricky because you went, oh, 3, third, no. You had to really read that carefully. And you know I like evil, nasty, mean questions, so prepare yourselves for those on the test. Lowest energy orbital listed below, of course that's 1s. It would be trickier if I put in a multiple choice and had things like 5s and 4d. Ooh. And then you have to go to your subshell filling diagram. Because, of course, 5s is lower than 4d if you follow your little lines. Okay, formula that gives the number of orbitals on any main energy level. Of course, that's n squared. We just talked about that. On numbers 11 and 12, I asked you to draw orbital notation, and I asked you to draw electron configuration notation. If you drew the wrong one, I marked it wrong. Because I'm testing you partly on being able to draw it, but I'm also testing you on if you know what that notation is called. So for orbital notation, 13 electrons. Orbital notation, we are drawing every single orbital. I am ashamed to admit to you how long it took me to realize how easy it is to remember that. Like, oh, orbital notation. You draw every orbital. I had been teaching it for a few years. Whatever. Sometimes I'm happier with my brain than other days. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, we're up now into the 3Ps. So we have 3Px, 3Py, 3Pz, and we only get one electron in there. So that is the orbital notation for an atom with 13 electrons. That was number 11. Okay, number 12, draw the electron configuration notation for chlorine. Well, the first thing we have to do, first thing you have to do is figure out how many electrons chlorine has. Use your periodic table. 17 is the atomic number, 17 protons, 17 electrons. So if we're doing electron configuration notation, this is where we don't draw the orbitals. We can skip that step. Now, if you still need to draw the orbitals, that's fine. All right, so I've got my subshell filling diagram drawn really badly. And I know that I'm going to go 1s2, 2s2, and I'll even cross these off as I fill them. 2p6, I'm now up to 10, 7 to go. And this is one way to shortcut it if you are interested in shortcutting, to not have to draw all your orbitals. And I do this when I'm warming up usually. So then 3s2 gets me to 12. 3p6 would take me all the way to 18. So 3p5. Okay. And that's your final answer. And I find just going through the subshell diagram and kind of checking them off as you fill them is helpful. And it's better than drawing all the orbitals in every single electron. Okay. For 13, we're asked what element is represented by the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. In the next chapter, you'll know a shortcut for this, but you don't yet. So we just have to add these all up, and we get 24 electrons, and this is chromium. Chromium. And I'll give you a problem like that on the test, pretty well guaranteed. So now I'm asking you to draw the orbital notation for something with 38 electrons. So again, I'm going to reference my subshell filling diagram. Okay, so if I'm going to do 38 electrons, I know I have to do 1s, 2s, 2px, 2py, 2pz. That'll get me up to 10. 3s, and I'm going to wrap this, though I don't like to do that. 3px, 3py, 3pz, and that gets me up to 10, 12, 16, 10, 12, 18. Oy vey. Okay, 10, 12, 18 at 3p. So after 3p, I have to fill 4s, and that's the thing to remember. So that gets us up to 20. So now we go 3D, and it's 3D1, 3D2, 3D3, 3D4, 3D5. That's all our Ds. After 3D, we fill 4P, so we have 4PX, 4PY, 4PZ. And then after 4P, we fill 5S. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Whew! Awful. Okay, for number 15, I asked you to give me some electron configuration for something with 54 electrons. So again, I'm going to do my own shortcut, and I'm just going to go through and check them off as I go. So 1s2, 2s2, 2p6, I'm up to 10, 3s2, 3p6, we're up to 18, And then 4s2, we're up to 20. Whoops. Okay. Then I'm going to go 3d10. So now, okay, I was up to 20, I'm up to 30. 4p6, we're up to 36. 5s2, we're up to 38. 4d10, we're up to 48. And we need 6 more. 5p6 gets us there. Now, to make this answer correct, you should reorder them. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6. Okay? So you should make sure that those are in the correct order. Because again, remember, that gives you a clue as to what's the highest main occupied energy level in this thing, which is the 5th. Okay, the last question was just being able to draw this correctly. Most people did fine with that. The only things I saw, a few people didn't want to put arrows on their lines or didn't want to draw their lines at all. Or if your lines wiggle and wobble, then they won't line up right and you'll end up filling in the wrong order. So be careful with that. And I think at least one person, maybe two, did the thing that I started to autopilot and do, where you go 4s, 5p, oh. So just have to watch that. Okay, that was it for the FIP.